Okay then, in this video we'll start off with problem number 47, or we'll finish up problem 47, and then we'll go on to the next group of problems in this section. We're looking for the derivative of the natural log of e to the x squared. And if we apply the properties of logs here, we would get that, notice that the x squared is an exponent, and when we raise the natural log, we find the natural log of e raised to a power, we can bring that power down first before we start. And when we do that in this case, we bring down the x squared, and now we have x squared times the natural log of e. Now another fact that you need to remember is that the natural log of e is equal to 1, and even though we're not using it here, the natural log of 1 is equal to 0. There is no natural log of 0. The natural log function is only defined for positive x values. It can't have an x value of 0. Well, the good thing then is that natural log of e is just 1, and so all we're looking for here is the derivative of x squared, which just comes out to be 2x. And we're done. So we're playing this properties of logs, properties of exponents game, and the more you practice this stuff, the better you'll get at remembering those and using them. And again, it's been a while since you've used them, but hopefully they'll all come back. All right, I'm going to go on to the next cluster of problems in this section. Okay, let's see how many of these we can get through on this 5-minute video. First of all, number 49, we have the natural log of 1 plus e to the 2x. Recall that we do have a formula for the natural log of a product is equal to the sum of the logs, but we don't have a property of logs for the log of a sum. That's a really big pitfall that people trip at. So there's nothing we can do with this one except that we know that the derivative of the natural log of anything is just 1 over that anything, and then multiplied times the derivative of the anything. In this case, the anything is the 1 plus e to the 2x. Derivative of 1 is 0. The derivative of e to the 2x, which is a chain rule by itself, is e to the 2x times the derivative of 2x, which is 2, and that left us with 2e to the 2x divided by 1 plus e to the 2x. Now you can't cancel those e to the 2x's there. Don't do that. E to the 2x in the denominator is not a factor of the whole denominator, although it is in the numerator. We don't have another one to match it in the denominator. So that should be it for that one. All right, with number 51, we really have a quotient rule here. I guess you could say it's a reciprocal function also, but if we treat it as a quotient, that should be fine. We have low d high, and because the numerator is a constant, the derivative of the numerator is going to be 0, so that whole first term will come out to be 0. So low d high is just 0. Then it will be minus the numerator times the derivative of the denominator. And sometimes if I don't want to do, if I'm not comfortable just writing the result of that derivative right in there, what I can do is this. I'll write the derivative that I need to find, kind of a placeholder for that derivative there, and then do the rest of the stuff, and then come back and fill in that next step. And remember, that's over low squared. Another place where students have some difficulty is when you have a sum, a binomial, and you square it. That's not e to the x quantity squared plus e to the negative x quantity squared. It's got to be treated as with FOIL. But we're going to leave it the way that it is, just like that. Now the only other thing we had to do with this then is to find the derivative of e to the x plus e to the negative x. The derivative of e to the x is just e to the x. And the derivative of e to the negative x is e to the negative x times the derivative of negative x, which is negative 1, and so that comes out to be minus e to the negative x. And so you end up with negative 2 times e to the x minus e to the negative x over e to the x plus e to the negative x quantity squared. Be careful, again, one is positive, one is negative. They're not common terms, and they cannot be canceled. Nothing can be done with that at that point except to leave it. Alright, so that's 49 and 51. We'll go on to 53, 55, and 57 in the next video.